Good morning to you all. I'm Josh Jamling with the project on handwritten Dzongkha alphabet recognition system or handars. I'm guided by Shamsu sir along with Yuntin Jamsu sir from Kyokushin College of Information Technology. These are the list of things I'll be presenting today. As to why I chose my project, the importance of preserving Dzongkha, our national language, while promoting it is essential. Our country possesses rich traditional scripts in paper and is only one disaster away from being lost. So this digitization of handwritten scripts ensures our protection, and optical character recognition (OCR) is one solution. This has been popular in various languages such as the Farsi text of Arab or the Devanagari text of India, but there has been no such system in our country. So such systems require handwritten dataset which is not available, and this has hampered progress in advancing technology. Keeping all these in mind, the aim of my project is to develop handwritten Dzongkha alphabet recognition system with the following objectives: to create a model to recognize handwritten Dzongkha alphabets, to create a handwritten Dzongkha alphabet dataset, to conduct literature on the related studies to find out the most appropriate methods to be used, to conduct training and testing of the model, and to find out the accuracy of the model. Going on with the literature review, according to Shinne and Shogyul, OCR is a method of processing and converting handwritten or printed text into editable form. Dasari, Dr. Mehta, and Steffi stated that there are 6 major stages in character recognition, namely image acquisition, pre-processing, image segmentation, feature extraction, and image classification. Yadav, Sanchez, and Morato used machine learning feature extraction to improve the rate of recognition and achieved an accuracy of 90% for printed Hindi text on document. Further, Abhadesh and Goyal in 2018 tried image segmentation algorithm to identify letters of Sanskrit by calculating the pixel intensities and then achieved an accuracy of 93.32%. Defu, Yun, and Wan tried using traditional techniques, namely support vector machine (SVM), and achieved an accuracy of 99.3%. And when using different algorithms such as k-nearest neighbor algorithm, they achieved 93.47%, and while using artificial neural network, they obtained 97.19%. So while the accuracy obtained was high, they concluded that the implementation time, which is also an important factor, was also long. They then tried using convolutional neural network (CNN) under deep learning and found that it had lower implementation time than ANN and had a higher accuracy of 99.45% as compared to SVM's 99.3%. These literatures concluded that CNN produced higher accuracy with shorter implementation time, and so CNN algorithm was used for this project. For the system architecture, CNN consists of convolutional layer, pooling layer, and a fully connected layer. If I briefly summarize how CNN works, in the given figure, Ka is given as input in the input layer, which then undergoes various processes before identifying the character. A convolutional layer is the first layer that extracts the features from the images given as inputs with the help of a kernel. A kernel is a filter matrix that is used to extract the features from the images. The output received from this layer is known as the feature map and provides information regarding the images, which are then sent to other layers to extract additional features of the input images. So after this feature map has been extracted, it goes through the pooling layer that aims to reduce the dimensions of the images in order to reduce the execution time. So this process continues depending on the number of layers specified by the user. So before finally passed on the fully connected layer, flattening is done. So flattening basically converts the data into a one-dimensional array for inputting it to the next layer. So we flatten this output of the convolutional layer to create a single feature, and then the last layer is the fully connected layer. So as the name suggests, the neurons, which are the basic units of a neural network, are connected with each other, and then this layer will classify the images based on its classes. So the first step of building a dataset, it starts with dataset collection. There are no fixed rules on how to go about in this scenario, but a common exercise is to make people fill up in boxes and then data crop out. I used flip charts which consists of boxes to help ease the process. These flipcharts were then cut into 30 exact boxes for the alphabets of Dzongkha and were individually handed out to people. So 3,000 samples were collected in total. So after this collection was done, thresholding of the images was necessary. So thresholding is a method of converting multicolored image into black and white image. This is necessary in order for the model to extract information and features from the machine more distinctively and easily. Next comes the cropping of the images. So at first I used to directly process, and it produced the lines of boxes along with the alphabets, which was not required. So therefore, I then used scanning and cropping using OpenCV that helped in selecting only the region that I want. So this is the example of how I use cropping using OpenCV. This was done repeatedly for each alphabet. So while most of the dataset were processed correctly, some of the images lost its pixels in the process. Erosion and dilation techniques are present to correct such images. So erosion basically erodes away the boundaries of the foreground object, and then it is used to diminish the features of an image, whereas dilation is just the opposite. It brings out the features. So for this project, erosion was not necessary. However, dilation had to be done on some of the uh, alphabets. Next is the data normalization. So image normalization refers to changing the value of the intensity of the pixels of the image. So as various images come with different sizes, this is mainly used to standardize and reduce the image size according to the user with no fixed value. All the images for this project was normalized into 32 times 32 pixel images. As this was the lowest value, the image could be standardized below which the images were not clearly visible. Next is the data augmentation, which is the method to increase the amount of data without collecting new data. It significantly increases the diversity of data available for training models. There is a image data generator class in Keras that consists of image shifts, flips, rotation, and brightness. 5 different images were produced using augmentation for each alphabet. And since there, I collected a total of 3,000 dataset, augmenting 5 images resulted in the total amount of 15,000 dataset. So these are the augmentation techniques: image shift, rotation, blurring, and contrast. So after the dataset had been prepared, uh, data labeling has to be done. It is just a process of adding relevant and useful labels to the dataset. This process requires manual naming, selecting, and moving the images in each of the labeled folder. The dataset for this project was labeled taking the Devanagari text dataset as the reference point. So I named the folder using similar naming conventions of the Devanagari dataset. So each folder contains 500 images. After the dataset had been prepared, developing of the model was done. So for initially, CNN requires number of layers to be defined and the kernel size to extract the feature. There was no fixed rule stating the number of layers to be defined. Therefore, I started off with 2 layers up to 5 with a combination of kernel sizes of 3 and 5 for each layer. As for the optimizers, um, Adam optimizer and RMS prop model were the two most commonly used optimizers as per the literature carried out by Ram Prasad Pujari and Apul Pai. So therefore, a basic model with various number of layers and kernel sizes were developed using these two optimizers. So the best result was given by a 4-layered network with the kernel size of 3 using the Adam optimizer with an accuracy of 98.59% and 13.85% as its loss. So therefore, the model for this project consists of 4 layers with a kernel size of 3 using the Adam optimizer. So after the basic model was designed, hyperparameters were included to effectively train the model. So these are basically the variables that determine how the neural network is trained. So the hyperparameters used in this project are the learning rate, activation function, loss function, epoch, and the batch size. Learning rate basically controls how fast the model adapts to learning. So in this case, the patterns and features of the images. And Benjo stated in his paper that the range of values to be considered for a learning rate is less than 1 and greater than 0.000006. The default value of 0.01 works for multi-layer neural network is what he concluded. And Oye suggested that for hidden layer units, there are two conditions. For models using one or two layers, logistic sigmoid, tangent sigmoid, or rectified linear sigmoid should be used depending on the experiments. And for a network containing more than two layers, rectified linear unit, ReLU, works best as it solves the problem of vanishing gradients. For the output layer, the same author concluded that we have to determine whether it is a classification or a regression task. And since this project is mainly for classifying the alphabets, so we then have to decide whether we want to use binary or multi-class classification. Since my project has more than one class, 30 classes in total, it is multi-class classification. So for multi-class, softmax with categorical cross entropy was used. And then initially for the model, when I trained the model for the epoch size of 80, the accuracy I obtained, uh, ignoring the accuracy, I firstly checked the loss and then found out that the validation loss, which is shown by the orange color, is greater than the training loss. And this showed overfitting of the model. And then the techniques
you
to
have 3 minutes left.
Thank you, ma'am. So way to overcome overfitting is using dropout. So we just ignores neurons during the training phase of certain set of neurons. So we can assign dropout of value between 0 to 1, and then I assigned a dropout value of 0.4 to the input layer and a dropout value of 0.2 to the fully connected layer before the output layer. So the figure below shows before using dropout and after applying dropout. And then when used dropout, the loss I got on the testing was quite less than the first model. So this was before using dropout. This was after using the dropout. So the model loss, the testing loss of the model was significantly lower. And then when I used the same values and tested for the accuracy, I obtained an accuracy of 98.4 on the training and 91% on the testing. So in a network, sometimes after a certain epoch, the model does not learn effectively. So to check on from which epoch the model does not learn effectively, I used callback. And in callback, there are methods known as early stopping. So early stopping stops the epoch on the number it does not, the model does not train further. So I monitored on the validation loss as this was the common property. So and then it stopped on the 17th epoch, stating that from the 16th epoch the model was not learning much significantly. So using this, I used 16 epochs, obtained the accuracy of 99.19% on the training and 91% on the testing set. So the model was then saved in H5 format, as this is the native way of saving the model by Keras. So it stores the weights and configuration in a single file. So after this, I then tested my model on a new set, unseen set, the testing set. So it consists of 10% of the total data set, which is 500. So the same model was then tested and obtained an accuracy of 97.2% with the loss of 17.62%. So for each class, F-score precision and the recall values were produced. So this is the F-score precision and recall values for each class. And then from this, we can conclude that our model effectively recognizes the 25th character of our Dzongkha alphabet Ra with 98% accuracy, and the least was the character Cha with 95.39%. That is all for today. Thank you.